Sometimes I wonder, does it always have to be only two end stations and one point-to-point connection? How can I expand the network to share data with more end stations? Basically, a point-to-point connection between any two computers on the network will be a good idea for both computers to communicate. But wait, that will be quite expensive because for any computer, I'll have to do a point-to-point connection from it to every other computer on the network to achieve a full connection. This approach becomes more difficult and expensive as the number of computers increase. On a second thought, if we put some form of device at the center and connect all computers to it, then it will be possible to have a multi-access network connection where any computer can use only one link to access every other computer connected to that link through the central device. The simplest device used to implement this is called a hub. But before we talk about the hub, let's understand what collision is. Hello guys, welcome to my presentation on physical layer devices, and we'll talk about the Ethernet hub. What is collision? Let's take a one-way road for example. You have many cars moving this way, right? What will happen if a car is moving in the opposite direction at the same time? That's collision in real life. In another example, you have a main pipe for supplying water. Mr. A needs water in his apartment. All he needs to do is create a branch, fixing a T-joint at this position, after which the flow will be extended to his apartment. In networking, a coaxial cable has only one copper wire at the core for transmitting signals. These signals are called baseband signals, meaning that they occupy the entire channel space, just like the car on the one-way road and the water through the water pipe. If you send and receive data traffic at the same time on a single wire, you'll have a collision. Now, let's talk about how link sharing works. It all started with the coaxial cable. You see, Ethernet is a technology that allows for a link to be shared, otherwise called a broadcast network segment. It is one where multiple devices can share one link by attaching extra connections to the link. Some data link layer protocols like PPP do not support this because in PPP only two devices are allowed to use a single link. With coaxial cabling, devices can receive signals on a link by tapping from it. They do this using a BNC T connector. With a BNC T connector, any computer that needs the shared data can attach itself to the link. The construction of this type of network begins with using a coaxial cable called a bus, and then any device that wants to tap from the bus will be attached to it using a BNC T connector. Finally, we terminate the naked ends of the bus using a BNC connector. We do this because the data sent by any computer will be transmitted till it gets to the end of the bus and then reflected back. This can also cause a collision with the ongoing transmission. By terminating it, signals reaching the bus ends will be absorbed or dissipated. Any segment in a computer network where collision can occur is called a collision domain. The bus network, however, has two major problems. 1. Any fault on the bus can tear down the entire link. 2. It can be very difficult to locate faults when they arise. So because of this, a bus connection was replaced by the star connection using a hub. A hub functions as a concentrator. This means the hub is the center of the star connection where all other devices connect to. A hub understands only signals, that is, layer 1 information, because it is a layer 1 device. Connecting devices to a hub is like tapping signals on the bus network in coaxial cabling. A hub will receive a signal from a device, copy the signal, and forward the signal to all other devices connected to it. All links connected to the hub are said to be part of a single collision domain. Hubs can also help overcome the 100-meter distance limitation of twisted pair cables. Assuming a need to transmit data to a distance of about 180 meters, divide the connection into two parts, terminate them, and connect to a hub. After 90 meters transmission, the hub reconstructs the signal and sends as a fresh signal headed for the destination device. However, a cheaper device to perform this function is called a repeater. In summary, a hub cannot be used to forward data to a specific destination. It receives a signal from one computer and always forwards to every other computer connected to it. Hubs are rarely used in today's networks because they cannot maintain private conversations between devices. They have been replaced by devices at data link layer such as bridge and a switch. This is because these devices understand MAC addresses and can perform specific forwarding of data based on them. Check out the questions on the next slide. Watch out for the data link layer, same time next week, to get a better understanding of how the Ethernet technology works. If you learned something from this video, please leave a comment, like, subscribe, and share so others can benefit too. Thank you for watching.